Okay, so welcome to today's lesson. Yesterday, I talked about, your exam. I said that you are going to have 60 questions, and you'll be given 90 minutes. Okay, and then the pass mark, you have to get 600 and above out of 1,000. Okay, and I talked about the course content. So this course has 5 modules here. Okay, so and we started looking at module 1, and in this module we did 3 slides. So we are going to continue with this, looking at this module. Okay, and then once we are done, we are going to look at module 2 as well. Okay, so it is very, very important that you know what networking is all about in this course. Okay, because this course deals mainly with how you protect the computer network from the attackers. So yesterday we looked at what is known as the OSI model and the TCP/IP model. These are the 2 models that helps us to easily understand how the network works. Okay, so we are going to continue looking at networking. So very, very important to know how a network works, because once you know how it works, then you are going to be in a better position of knowing how to protect it. Okay, so we are going to look at common network devices. Forward, network devices are the basic components of a network. When planning and constructing a network, you need to deploy and configure the network devices to meet network connection or network security requirements. Objectives: upon completion of this course, you'll be able to describe Huawei common network devices, describe the functions of network devices, and then log in to network devices and perform basic configurations. So in this last part, you are going to learn how to configure Huawei devices using the commands. Very, very important. So you can configure the Huawei device using the graphical interface, or you can use command lines. Okay, command line. But what is very, very important for you is to know how to use command line. Very, very important. Contents. So we'll start with basic network devices. Okay, so this is the campus network security deployment scenario. Okay, so what we have here, the branch or partner, and then these can be our remote employees. And then this is the internet, where the viruses and other malware come from. Okay, and then here if you see here, we have anti-DDoS. So yesterday I talked about a DDoS attack. This is distributed denial of service attack. We are going to look at it even today. So the network can have anti-DDoS to protect your organization from DDoS attacks. Okay, so the thing is that I said that a DDoS is an attack which comes from so many devices. Okay, so the hackers, what they do is they do infect the devices that are vulnerable on the network, and they create what is known as the botnet. Okay, so they program the botnet to send traffic to a certain device, to bombard the device with traffic, to overwhelm it with traffic. Okay, all right, so these computers which are infected, we call them zombies. All right, so, and the network which is formed by zombies, we call it the botnet. So you find that you can even buy a botnet on the dark web, which you can use to launch an attack. Okay, that's how it is here. So very, very important that you have this device, anti-DDoS, to protect your organization from DDoS attack. Okay, and then here, what you see is the DMZ. This is, demilitarized military zone, DMZ. So what do we put in the DMZ? In the DMZ, this is where we can put the servers, and we want members of the public to have access to these servers. So these servers, you put them here in the DMZ. And you can see one of the devices that we can have in the DMZ. It is the Agile controller. The functions of Agile controller is access control, okay? Controlling access in our network, okay? And then what we have, these are what we call the firewalls, okay? So these are the devices that, you'll be configuring in this course, okay? So the firewall here, what it does is to filter the traffic that is coming into our organization, okay? So we are going to configure the policies here, which are going to either allow the traffic to enter into our organization or not, okay? So the firewall, we can configure it in such a way, we can say that anything which comes from the internet, it has to be blocked. But anything which came from our internet here, it came from here, it went to the internet, and when it's coming back, it has to be allowed, okay? So these are the firewalls. So the purpose of them is to filter the traffic which is coming into our organization. So this is a very, very important component in networking security, all right? And then here, this is the data center. So this is where we can put the servers where we do not want members of the public to access, okay? And one of the devices that we can put here is what we call a network intrusion prevention system, okay? Network intrusion prevention system. So what this device, does is to block That is to detect malicious traffic and then block it. Okay? So it is also a very, very important device to have, you know, when you are protecting your organizational network. And then you can see here, this is a virtual next generation firewall, right? So we have the idea of virtualization, okay? What is this virtualization, right? So with virtualization, you see we can, instead of having all these 4 servers that we are seeing here, we can have just a single server. And then in this single server, we create the virtual servers, okay? And that is the technology which is being used in data centers. So that, you know, instead of having so many physical servers in the data center, we can also have virtual, you know, virtual servers. So how do we protect these virtual servers? This is where we can use now virtual next generation firewalls. Okay, so we have virtual next generation firewalls to protect the virtual servers. So the thing is with virtualization is that on this same server, we can be using the same power, the same processor, the same RAM, which will be powering the virtual servers. So in this single server, we can have maybe 4 virtual servers, okay? So virtualization helps us a lot in terms of space, okay? So the 2 devices that we have here is network intrusion prevention and virtual next generation firewall, okay? So these are some of the devices that we can have, you know, to protect our network. Okay. Now, apart from those security devices, we also have what is known as, you know, the switch. Okay. So these are switches here. Okay. So we have 2 types of switches. This is what we call a traditional switch or a layer 2 switch. So we use the switch to connect these devices, okay? End devices, they are connected to the switch. What are end devices? The computers, the servers, you can see the IP phone here, okay? So this is a switch, a layer 2 switch. And then we have these are what we call layer 3 switches, right? So it is not only, you know, able to do switching, but it is also able to do routing, okay? So these are what we call layer 3 switches. And then these here, what you see here, these are what we call the routers. Okay, these are the devices that we use to connect to the internet. We have the routers here. Okay, so when protecting our network, we can also have what is known as you know, software-based firewall installed on these routers which are facing the internet. They are facing the internet. Therefore, the internet is a very dangerous place. So we have to try by all means to protect these devices which are facing the internet. Okay, all right. So we'll start now looking at these components of the network one by one. we are starting with a switch. So this is a switch here. So you can see we have to connect these computers to the switch, okay? So a switch works at the data link layer and forwards data frames. You see, you remember when we looked at the OSI model, you know, it has 7 layers, okay? So now we have what we call the physical layer, or layer 1. It is followed by data link layer. So one of the devices that you find in the data link layer is a switch, okay? And of course, what type of PDU are we dealing with when we are in the data link layer? We are dealing with frames, okay? So, you know, even yesterday, you know, this, I told you that I can assume this is my office, okay? Then this is a switch. So this type of a connection is what we call a local area network or Ethernet, okay? And a PC must have one, the IP address, a unique IP address, and of course, also the MAC address, or what we call the physical address, okay? So when this PC wants to connect to this one, here, they don't use IP addresses. They use MAC addresses, okay? They use MAC addresses. So the job of the switch here is to receive these frames and sending them to other PCs, okay? Forwarding on switches. So we have 3 types of forwarding. The first one is flooding, okay? So what is flooding? So this is when, by the way, the switches, they come with different numbers of ports. So in the port, that is where we connect the PCs, okay? So the switch will receive the frame through this port, and it will forward the frames to all other ports, apart from the port where it received the frame. So this is what we call flooding. And then we have forwarding. So with forwarding, the switch receives the frame from this port, and then it is going to forward it to the port where that frame is going, okay? So the switch is very, very intelligent. So when you buy a brand new switch, when you connect the PCs to the switch is going to learn the MAC addresses of those PCs you have connected to it. So it learns the MAC addresses and put them in the MAC table, right? So when it receives a frame, it opens that frame and check the MAC address, okay? So it is going to check the destination MAC address, all right? So once it has checked, then it will be able to forward that frame to the correct port, okay, to the correct destination, all right? So the other forwarding is what we call discarding. Discarding, this is whereby a switch receives the frame and drops it. That is what we call discarding. Okay, so these are the ways in which a switch forwards information. Okay, so initial state of switches, all right, so you have bought a brand new switch, you have connected host A, host B, and host C, but before connecting them, this is what you have in the MAC address table. Nothing. So what you have is the MAC address and the interface. Okay. So once you connect, let's say you connect host A to the switch, this host is going to send its MAC address to the switch. Okay. So this is the message. We are going to have the destination MAC and the what? And the source MAC. Okay. And this is an ERP. Okay. So once the switch receives this information, you can see it is going to record. This is the MAC address of host A, this one here. And you can see that the switch learned about this MAC address through this port, gigabit 0/0/1. So you can see that this is also what? Recorded. Okay? So this is how it is. So the switch will continue learning until until all these devices, they have submitted their MAC addresses to the switch, and the switch will keep this information in the MAC address table. Okay. Forwarding data frames. All right. So when the destination MAC address of a data frame is not in the MAC address table, or it is a broadcast address, the switch floods the frame. So you can see we have two ways in which the switch can flood, okay, the frame. One, the destination MAC address of a data frame is not in this MAC table. Or if the data frame is a broadcast, then the switch is going to send that frame to all the ports apart from the port where it received the frame from. Okay. Response from a target host. So the switch unicasts the reply from host C to host A based on the MAC address table. All right. So you see, when host C is sending information, the switch will receive that information. It will receive a frame, in fact. It will open the frame and check the destination MAC address, right? And then it will compare with the information that it has in the MAC address table, okay? From the MAC address table, it will be shown that this MAC address was learned through this interface. So it will receive this information and forward it through this port here, okay? That's how things work, okay? So sometimes they would ask you, a switch, what type of a device it is. So you just have to say, a switch is a layer 2 device, okay? A switch is a layer 2 device. From the switch, we move on now to what we call the router. Okay, so the function of the router is to forward data packets between different networks. Okay, so here, this, I can say network 1, where we have host A, and then this is network 2. Okay, so these are 2 different local area networks. So when you want to connect 2 separate local area networks, you use a router. Okay, you use a router. So let's say here at UNZA, this, UNZA is a lane. And then we have another lane, another campus in Kitwe, all right? When we want to join these 2, we use a device called the router. Okay, so here you can see we have 3 routers. And this is how it works when you are sending something on a device, right? So you'll be going down the model, starting from the application layer. And here, when you'll be going down, the headers will be added to data in a process called encapsulation. Okay, so when we reach the physical layer here, then we'll pass through the cable. So here, in the physical layer, we are going to change the 1s and 0s into signals. Okay, so when we reach this router, we are going to start going up. Okay, and when we are going up, the headers which were added here, we'll start removing them one by one through a process called decapsulation. Okay, so when we reach the data link layer here, the data link header will be removed. Okay, so here we have to check for the MAC addresses, the destination MAC address and the source MAC address. Okay, and then we'll move on to the network layer, where now the network header or the IP header will be opened to check for the destination IP address. So what you must take note is that when we're dealing with the data link layer, here we're dealing with frames. Here we're dealing with MAC addresses. And when we reach the network layer, here we're dealing with IP addresses. Okay, so the router is going to open the message and compare the destination IP address in the message with its IP address. Okay, after it has found out that they don't match, then the router is going to close that message. Okay, and we'll start going downwards. We'll be closing now. Again, like this, again, it will be the same process, just like that, okay, until we reach host B, okay? So what you must take note here is that when we are moving from this local area network to the other local area network, we need to involve the IP addresses, okay? And the router is a layer 3 device, okay? Or it is one of the devices that we have in the network layer, okay? So this is how things work, but, very, very quickly, okay? So we can also use the router to select the best path to our destination, where we are going. Okay, firewalls. So this is, an organization where we have headquarters here. There is the branch, data center, production area, and this is the internet. So the headquarters is connected to all these through the internet, and the internet, it is a very dangerous area. So we can protect the headquarters and the branches by using the firewalls, okay? By using the firewalls. Okay, so comparing firewalls with switches and routers, the primary functions of routers and firewalls is forwarding, whereas that of firewalls is what? Controlling traffic, okay? It is controlling traffic. So you can see here, this is the switch. The purpose of the switch is forwarding information, and then for the router is controlling the traffic, and then for the routers is forwarding. So this is the history of the firewall development. So you can see here that the first firewall was made in 1989, and it was called packet filtering firewall. Okay, it was filtering the traffic by using what we call access control lists. Okay, so it was just based on access control, and this was called the first generation of firewalls. Okay, then later came the proxy firewalls. Okay, so with the proxy, how it works is like this. When the device wants to go to the internet, it has to go to the proxy. Okay, the proxy will do the searching and whatever for that device. Okay, but this technology, the disadvantages with this technology is that for each application, you have to develop a separate proxy, and that takes a lot of time. Okay, and then in 1994, there was what is known as stateful filtering. Okay, so here advances were made such that the firewalls now started tracking communication by recording it in the session tables. Okay, so here, this was indeed very, very good, because the firewall now was reliable. Okay, and then in 2004 came UTM. Okay, a UTM, this is a device with so many devices inside it. So within the UTM, we can have antivirus, we can have a firewall, we can have intrusion prevention system, we can have email filtering, we can have data filtering, and so on. Okay, but the problem with UTM was, delays in detection, as well as it was becoming very, very slow in processing information. Okay, and then in 2005 we had what is known as deep packet inspection technology. In 2009, new, that is, we had new generation firewalls. That is, the firewall was now not only tracking the content, but it was able to track the user as well as the applications. Okay, so this is, very, very important, and even up to date, this is what is being used. Okay, the next generation firewalls. Okay, firewall zone. So a security zone is a local logical security zone, okay, or a network connected to one or more interfaces. So the thing is, what we do on a firewall is to divide it into zones. So we can have the trust zone here, the untrust zone here, and the DMZ. And what we can do is to configure the policies on this firewall such that we can say the traffic which is coming from untrust zone can be allowed to go to the DMZ. And the traffic which is coming from the DMZ can be allowed to go to untrust zone. But anything which is coming from the untrust zone trying to go to the trust zone has to be blocked. So that's how we protect our organization. Okay, and we can also configure a policy where we say anything which is coming from the DMZ trying to go to the trust zone has to be blocked. Okay, and of course, the firewall has 4 zones by default. Okay, it has the local zone, the trust zone, untrust zone, and then the DMZ. Okay, so these zones, they have different security levels. Okay, different security levels. So the trust zone can be given, let's say, 85, and then the local zone, which is inside the firewall, it can be given the level as 100, and then these two, they can be given the same level, let's say 5. So when they have the same levels, it means that data can be able to move from this zone to this other zone without restrictions. Relationship between firewall, security zone, and interfaces. So we have some questions that we need to answer here. Does the firewall have 2 security zones with the same security level? Does it? The answer here is no. They're supposed to have separate, levels. Does the firewall allow the same physical interface to belong to 2 different security zones? Here, the answer is no. And then, can the different interfaces on a firewall belong to the same security zone? Yes. So what we have here, it is a zone, but we have 2 different interfaces. No, we have two same interfaces in the same. Sorry for that. Here, what we have, this is gigabit 1, 0, 0. And then this is gigabit 001. So we have 2 different interfaces in the same security zone, which is a trust zone. So here, the answer is yes. Okay. Device initial login. All right. So Huawei devices, they use an operating system called the Versatile Routing Platform, VRP. Okay. So this is the operating system which Huawei devices uses. So VRP is a network operating system. You know, it is a software platform that supports multiple types of devices. It provides TCP/IP routing services. Okay, so how do you use this VRP? Okay, we use the command line. Okay, what we call the CLI. And this CLI has different views. So you can see the first view is what we call the user view. Okay, and how do you know that you are in the user view? It is because of these brackets here. Okay, this prompt, the brackets. Now, when you want to move from user view to system view, you use this command here, system view. And the goodness with this operating system is that there's no need for you to type, you know, this whole command. You just have to type SY, and then you press the tab key on your keyboard, and the tab key will be able to complete the command. Okay, so you move on to the other view. So this view here is what we call the system view. Now, how do you know that you're in the system view? Because of the shape of these brackets. As you can see, they have changed. Okay, all right, so when we are in the system view, this is where we can change the configurations of a Huawei switch, a Huawei router, or a Huawei firewall. Okay, so how do you configure the interfaces? So you can configure the interfaces with the command interface, and then you put the interface here. Once you press enter, this is what we call the interface view. So this part here is under this interface. Okay, and then we have also another view which is known as the protocol view. So this is the protocol, OSPF, we talked about this. So once you press enter, this is what is known as the protocol view. Okay, full help. So the other goodness with this, networking operating system, VRP, is the question mark command. So the question mark command, it is going to help you which command, come here. So question mark, and it will list the command. So once you look at these commands, you'll be able to know which command you are going to pick. Okay, so you can start the command as display firewall, and then here you have forgotten the command. What do you do? Question mark, and then you'll be able to list the commands, and you'll be able to look at these commands and choose the right one. Okay, so that is full help, and then we have partial help, where maybe you have just remembered the first letter of the command, so D, and then question mark, and then you'll be able to list the commands. So this is what we call partial help. And then the tab key, I said earlier on, you don't have to write the whole of this command. You can just type info dash, and then you press the tab key on the keyboard of your laptop, and it will be able to complete the command. Okay. Configuring interfaces. So this is now the graphical user interface, the other way of how you can configure Huawei devices. This is the simpler way, where, you know, interface name, you write the name there, okay? Virtual system, of course, is public. And then you can select the zone. You select the mode, and then the type of, that is, how is the interface going to be given an IP address. If you pick static, it means you're going to enter manually the IP address. If you pick DHCP, it means that the DHCP server is going to give this device the IP address. Okay, configuring the routes using the graphical user interface. Of course, this is the USG. This is Huawei Firewall. So when you are told to configure the routes, you have to go to networks. And then if it is static route, you pick static route here. And then, you know, the protocol, is it IPv4 or IPv6? You pick, and then you enter the values. Okay. Overview of device logging management. How can we manage Huawei devices? They can be managed in 4 ways. 1, through the console, Telnet, SSH, or web, okay? With console, this is where, you know, you have bought a brand new Huawei device. So what you do is you get this device, and we have what is known as a console cable. Okay, so you get the console cable and you plug it in the console port. Okay, and then you take the other end of the cable, you plug it into your laptop. Okay, and then one of the softwares that you must have for you to reach the command line of that device you have plugged to your laptop is PATI or Telnet. Okay. Telnet and SSH, we use these to manage the devices at a distance. So what is recommended here is SSH, because whatever you do with SSH is encrypted. And then anything you do with Telnet is in plain text. So when this information has been intercepted by the attackers, then they can be able to have that information. Okay. All right. So this is PADI. That is, once you have connected the console cable to your laptop, you are supposed to open this device, this software called PATI. Okay. Apart from PATI, you can have Telnet, and in our labs, what we will be using is CRT Secure. Okay. So these are the configurations that should be on PATI, Telnet, or CRT Secure. So once you have this, then you can click OK, and then you can go to the command line of that device you have connected to your laptop. Okay. This is web logging. Okay, so by default, you can log in the device through gigabit 0000. Okay, and of course, what you do first, you go to the web browser, and then you put in this, address, and then once this pops up, then the default username will be admin, and then the default password will be admin with capital A at 123. So this is when you want to access the graphical user interface of a Huawei USG firewall. Okay. Configuration management. So here, when you want to configure using the web interface, you have to enable HTTP or HTTPS. So what you do, you go to System, and then here, Service Settings, and then you just have to enable HTTPS. Okay. How do you configure a web administrator? Okay. On the Huawei USG, you go to System, Administrator, you pick Add, then you can add the name there of the administrator, the type of authentication, you key in the password, you confirm what will be the role of this person, and then the access method. So if it's through web, you tick web there. Okay. How about configuring the login interface? You go to network, interface, and then you can pick whatever interface you'll be using for management. Then you can put in the password there. And of course, you can even select, the access methods. Okay. Now, if I want to be using Telnet, how do I use it? How do I do it? It's System, Service Setting, and then you enable Telnet. How do you add the Telnet admin? It's System, and then you go to Admin, and then you add. So you can put the admin name here, the type of authentication, okay, the password, the role of this person, and the way this person is going to be accessing. Since we want him to be using Telnet, we tick Telnet there. Okay. All right. How about SSH? So this is when you are using now the command line. So you go to the system view and you enter this command, stelnet server enable. Okay, and then you configure service management enable, service management SSH permit, and of course you're supposed to create the key with this command, RISA, the type of the algorithm that is going to be used, followed by this command, local key pair, and then create. Now, which interfaces are going to allow SSH? So you're supposed to configure the VTY user interfaces. So this is the command, user interface VTY, 0 up to 4. So this means that 5 ports are going to allow Telnet. You start from 0, and then followed by protocol inbound or authentication mode. We are going to use what is known as AAA. We are going to look at AAA in future. And then how do you create the SSH administrator account? Is AAA, and then manager user, you can put any name here. Service type, we want SSH. The level, we want 3, and then password cipher. So if we say password cipher, it means the password will be encrypted. So you can put whatever password you want here. Okay. How do you create an SSH user? these are the commands. So SSH user, you put the name, and then followed by this authentication type, password. And then you repeat the same thing here. Service type we want as Telnet. Okay. Now here, if a Huawei device functions as an SSH client, you're supposed to enable the SSH login function on the client by using this command, SSH client first time enable. So very, very important for you that you know these commands. So if you are stuck somewhere, of course, you have to use a question mark. Okay. So some basic system configurations. All right. So we have different types of files. We have what is known as the saved configuration file. So this is the configuration file used for the next startup of the Huawei firewall. Okay. Current configurations. These are the current configurations on the firewall. Okay. Save the configuration file. We use this command to save whatever we have configured. So when you're configuring any Huawei device, you have to save the configurations. Okay. Erase the configuration file. This command is going to restore the device to its factory settings. Okay. And then we have configure the system software and configuration file for the next startup. And then of course we have to restart the devices. All right, so how do you upgrade, okay, the Huawei firewall? You have to go to system, and then you choose system upgrade. From there, you can come here, you click on one-click upgrade, where the upgrade will be done automatically. Okay, how about the issue of license? So a license is provided by a vendor to authorize usage scope and validity period of the product features. So you find that if you buy a certain, license, and if it doesn't have the features that you want, you can buy another license with more features. Okay, the quiz. So what is the default login IP address used in web login mode? Which one here? So we saw that this is the one, 192.168.0.1. So as I said, in this course, make sure you can only pass by studying and not any other means. And I told you that when you go into the exam, you take your time, you relax, you don't have to panic. You read the question and understand it, and then you go to the answers. Sometimes you can use elimination method because some answers don't make sense at all. That's how you do it. Okay, so move on to our next lecture. Just a minute, excuse me. Okay, so this one is called Common Information Security threats. Okay, forward. Information systems are often vulnerable and have sensitive confidential information that needs to be communicated. Therefore, they are under threats in various scenarios and through various means. This class uses some case studies about common attacks to introduce possible threats to the information system. Objectives. Upon completion of this course, you'll be able to categorize information security threats, describe common information security threats means. This is the content. So we are going to start with current situation of information security threats. So we have endless security incidents. You know, we hear of data breaches every day. A data breach is when information has been disclosed to unauthorized users. Okay, so we have everyday attack through malicious code. So malicious code is also called malware. You know, we looked at this event in 2017 when we had WannaCry ransomware. Okay, so here, the systems which were vulnerable, their information was encrypted such that people couldn't have access to their information. You know, the hackers were demanding a ransom to be paid. Okay, and then we have communication process hijacking. So this happened in China in 2017 when people were upgrading. Now, in the process, the hackers hijacked the software upgrade. So instead of installing the software, people were installing the viruses. Okay. And then here we have personal information breach, where we have more than 90% of telecommunication fraud is targeted fraud connected using precise information of citizens. Of course, when you have got a data breach, you know, the hackers, they have your credit card information and so on. You know, they can be able to sell that information or use it to make, you know, fake credit cards. And then we have also DDoS attacks. So, of course, this happened in 2018, February, where the popular online game, Final Fantasy 14, suffered a DDoS attack for 3 hours. So here, the gamers couldn't play the game for 3 hours. And of course, the company running this game, they suffered losses. And then in November 2016, 5 major banks in Russia, they suffered a DDoS lasting for 2 days. So you can see what it is here. We mean serious business. Therefore, the institutions must be protected at all costs. Now, imagine they suffered DDoS attack for 2 days. It means that these banks, they lost, you know, a large amount of money. Stuxnet. So this started what is known as cyber warfare. So this incident, it happened in 2011 in Iran. So the situation here was that Iran was, you know, enriching uranium. Okay. Now they built this nuclear facility, and they knew that it could be under, you know, cyber attack. So it was air gapped. What do I mean? this facility wasn't connected to the internet. Okay, so it is believed what the Americans and Israel did was to find someone who was working in that facility. So that particular person was given an infected flash. So he took that flash and went with it into the facility and plugged it to the computers which were there. So that's how Stuxnet, moved from the PC to the centrifuges. Okay. Now, the situation was that the engineers who were operating this facility, to them, everything was okay on the screens. But meanwhile, in the background there, the centrifuges were being rotated at a very fast speed, such that they got spoiled. So this hindered Iran from enriching uranium, okay? So this was the first, worm which was able to attack a physical infrastructure. So Stuxnet, it was a computer worm, which means it had the capacity to move over a network, okay? It exploited mobile media to implant what? Viruses. Of course, here, somebody had to go with an infected flash, okay? So it was the first worm capable of targeted attack of physical infrastructure facilities, okay? And of course, it employed multiple attack means. Imagine the engineers, they are there, they are seeing on the screens, everything is okay to them. Meanwhile, there's something wrong, going on. Then, this Stuxnet, it went on a loose, where now it infected over 45,000 networks worldwide. So far, this is the most sophisticated cyber weapon in history. So you can see to the extent where now, where we are going, okay? And when it comes to cars, now you find that the cars, they are computerized. Hackers are able to hijack the car, then speed it off, and then turn it maybe into a tree or into a ditch, and so on. So this is the world in which we are living in now. Evolution of information security attacks. More sophisticated attack means, this is what we have. So a major attack usually requires sophisticated deployment, long-term incubation, and a combination of multiple attack methods to achieve the ultimate goal. Okay, diverse attack purposes. So the attack targets range from targeting personal computers to being used to influence the economy, So hacking is able to influence the economy. Hacking is able to influence the politics. We know this. Hacking is able to influence war, energy. That's how it is. So forms of attack largely unchanged. So current attackers still use viruses, phishing, and other methods. Okay. Security threats categories. So we have threats to cybersecurity, and these are DDoS and network intrusion. And then we have threats to application security. So these are operating system vulnerabilities, viruses, phishing websites, and data breaches. Okay. So when we talk of phishing websites, these are fake websites pretending to be real websites of the banks. So once you enter your information there, then the threat actors will be able to capture your information. Threats to data transmission and device security. So this is communication traffic hijacking, man-in-the-middle attacks, unauthorized logging to the system, and then weak security protection for wireless networks. So threats to network security. All right, so we have an attack here which happened in 2016 to this DNS service provider done in the US, okay? So DAN is a company which is able to offer DNS services to other companies. So what happened here was that the hackers, they infected IoT devices, that is the routers, DVR, IPC, okay, as well as, you know, what is happening now, you find that we have the networks for air conditioners, the networks for the electric bulbs, okay? So all those, they were infected with malware, and they were programmed to send a large amount of traffic to this company, to the servers of this company, okay? So the servers were overwhelmed such that legitimate users couldn't access the services. And a number of websites of different companies were also affected, okay? That's how this attack was. So this is the process of a Mirai attack, okay? So what hackers are looking for are Telnet ports on IoT devices, which are, you know, always open. So they look for weaknesses in these devices, infect them, and then what they are building is what we call a botnet. And then they're going to load the attack module into the zombies, and finally they will launch an attack that is sending a large amount of traffic to a particular target. So this target will be overwhelmed with information. You know, bandwidth will be consumed. CPU power will be consumed. RAM will be consumed. You know, so legitimate users won't have access to the services which they want. Okay. Scanning. So scanning is a potential attack action. It does not directly interrupt network devices. However, it gathers relevant network information before an attack. So, before an attack, the hackers, they do a process which is known as reconnaissance, okay? Reconnaissance can be compared to a thief coming into a neighborhood. You know, he will try to see whether you have got a dog and so on. That is what hackers do. So they do what is known as address scanning, where they would send the pings to see whether they'll be able to receive replies to certain IP addresses. So from this, they can be able to know which systems are active or are connected to the internet. After that, they will do a port scan. Remember, we looked at ports, well-known ports yesterday. So these port numbers, they are related to the services. Okay, so if they see that port 80 is open, it means that they have web services, you know. If they see that port 21 is open, it means that they have got file services and so on. So it is through port scanning. So from there, they'll be able to know the services that are on the machine. So this is how hackers work. Okay. Spoofing attack, obtaining the control permission. So spoofing attack rely on trust. Okay. So this PC trusts this one. Okay. So what it's going to do is to get the IP address of this and pretending to be A. Okay. That is what we call address spoofing attack. So here is a DDoS. So this hacker here is called a bootmaster. And then the server here is called C&C, control and command. So these are the PCs that have been infected. You know, so sometimes you cannot know that, you know, your laptop is involved in a DDoS attack. You know, so these PCs which are infected with a boot, they are called zombies. And this network is what we call the bootnet. So they are programmed in such a way as to send a large amount of traffic to a target to this network here. So they are going to exhaust, as you can see here, network bandwidth. They are going to exhaust server resources. What are server resources? The CPU, the processor, as well as the RAM, which is the memory. Okay. Defense measures for cyber attacks. So we have seen what can we do? Okay. How do we protect our organization? We can protect our organization with firewalls, by deploying the firewalls, by having anti-DDoS devices, threats to applications security. So here we're looking at application security. So we have an example of a worm attack against Weibo. So Weibo, this is a Chinese Twitter, which was hit by a worm that affected over 30,000 users in less than an hour. So this is what happened. So the attacker created a user account. You know, after creating it, he infected it with a worm. And then he did send the malicious link to the public section. So now through phishing, of course, for people to click on the link, it might be attractive. So phishing, it works on our minds. Okay. So it was enticing to these users. They clicked on the link and they also became infected, spreading the worm. So these infected users' accounts automatically posted and send out private messages to their followers. Okay. So you can find that infected messages increased drastically, infecting a large number of user accounts. And this, of course, took down Weibo. So this is an application attack. Okay. Threats brought by vulnerabilities. What is a vulnerability? This is a weakness or a defect in the implementation of hardware, software, or protocols, or in system security policies. They allow attackers to access or damage systems without authorization. So if system vulnerabilities are not fixed in time, the following attacks may occur. One is code injection attack. Okay. Code injection attack, cross-site scripting attack, cross-site scripting attack. So this is an attack where your website has a vulnerability. So the hackers are going to inject it with a malicious script. So anyone who goes to that website, and if maybe his browser or her browser is not updated, then it's going to get what? Infected. Okay. Malicious code propagation as well as data breach. Phishing. So this is a cyber fraud, and it can happen in so many ways. For example, by using fake websites, you create this website to be exactly like that of Zanaco, such that when the users go there, they go to online banking, they key in the details, you capture their details, okay? Or it can be through maybe in your organization, you have got access to this same document, right? And that document becomes what? That document becomes infected, okay? So phishing generally, it works on our minds. Malicious code. So when we talk of malicious code, this is a computer code that is deliberately developed or constructed to cause threats or potential threats to a network or a system. So with malicious code, we talk about Trojan horse, worm, viruses, and backdoor. Okay. So a Trojan horse, this is a program which you are thinking that it is a legitimate program, but in the background, it is doing something else. And then a worm, this is a malicious program which is able to move over the network on its own, okay? And then the virus, it needs a file to spread, okay? And also to multiply. That's a virus. So it needs a host. So of course, how do you spread the viruses? In your flashes. So a virus would need a flash to move from one PC to the other. And then we have the backdoors here, which the hackers, they can create after infecting your system, or maybe it is for the developers who have left these backdoors and threat actors have found it, which they can be using to, attack your system. Okay. Defense measures for application attacks. What can we do? So we need to regularly fix vulnerabilities. How do we do it? We do it through vulnerability scanning. That's why it's very, very important that apart from this course, you also do ethical hacking, or what we call penetration testing, okay? So there are tools that are used in vulnerability scanning where you look for vulnerabilities. After you have found them, then you patch, you mend them, okay? Now, you have seen time and again, Microsoft releasing the patches. As I said it, yesterday, an operating system is made up of millions of lines of code, and this coding is done by humans, so they are bound to make, mistakes. So once the coders have made a mistake, they create what we call a vulnerability, and once this vulnerability has been found, they are able to create what is known as a patch to patch it. Okay, a patch. For example, if you have the hole on your clothes, when you get a piece of cloth and then you mend that hole, that is what we call patching. So we need to do regular vulnerability fixing in our organizations. We have to improve information security awareness. So security is for everyone in the institution. So you have to constantly look out for suspicious websites, suspicious links. Okay. And then protection through professional equipment. For example, firewall, okay, the WAF, okay, as well as antivirus software, okay. So we use the WAF to protect the websites, okay. So let me just take you back here again on phishing. What happens in phishing? The word phishing, it came from, you know, when you go fishing, what do? You carry a net and then you cast it. Okay. So here, what hackers do is that they would send a number of emails to a lot of people, hoping that one of them would click on a link. Okay. That's how it is, you know. Sometimes the link can be enticing, whereby you are told to key in information and so on. You know, sometimes, you know, it said, you know, you have won something, so we need your details. And then you give in your very important information. That is on phishing. And we have different types of phishing here. Yesterday, we looked at what is known as spear phishing, which is targeted phishing, where you target an individual or you target a company, okay? There's another type of phishing, which is smishing. That is phishing through the use of SMS, okay? And then there's another one, which is called, another one, which is called whaling. So with whaling, this is where now you target big people in an institution. It is called whaling, okay? So different types of phishing are there. So threats to data transmission and device security, interception of user communication. So it happened that, you know, NSA in the US is able to listen to encrypted communication between Google, Gmail, and Yahoo users on the cloud, you know. And then, of course, Snowden, a whistleblower from NS, he said, you know, as long as you have made a call or you have been on the internet, you know, the NSA, they know you. So that's how it is in the world there. The Tumblr user information breach. So we have the microblogging website Tumblr, where the hackers hacked it and did steal information. You know, the company stated that there wasn't any damage to user information, but the fact was that the hackers decrypted the information because it was encrypted using a weaker algorithm. Okay. Threats in communication processes. So in communication process, we have threats such as man-in-the-middle attack, the data transmitted that is not encrypted, users who are using weaker passwords. Okay, so you are supposed to use a strong password. What is a strong password? It is one with at least 8 characters. And then it must have uppercase and lowercase letters. It must have a number and at least a special character. That is a strong password. Okay. User identity not authenticated. So this is what we call device security risks. Weaker passwords, user identity not authenticated, and then this is transmission security risks, which is through, you know, man-in-the-middle attack, where the hacker has to be between 2 people, listening and correcting information, and then transmitting the information which is not encrypted. So this is man-in-the-middle attack, okay, where the hacker will be between two people collecting information from them. The consequences, of course, will be information tampering and information theft. Information not encrypted, okay? So if information is not encrypted, information security may be compromised. However, even if data is encrypted, information may be stolen and cracked. Therefore, we believe in strong encryption, okay? So threat prevention suggestions, you have to encrypt information before storage. You encrypt information in transit, and then you see here, you have to use strong encryption algorithm. And the one which is recommended now is AES, Advanced Encryption Standard. Authentication attack. So an attacker obtains user's identity information, but still means. So this is where now the attacker gets the user identity authentication information and uses that information, to steal sensitive information or to carry out illegal acts. So what do we do with authentication attack? Make sure, of course, we must install the genuine antivirus software, and it has to be up to date, okay? You use strong password, and then you reduce the relevance between different passwords. So the idea of using odd password, you're not supposed to be using odd passwords. Okay, and then we have the quiz here. As I said, take your time in reading the questions in your exam. Which of the following are threats to application security? Application security, the threats. One, we have got injection attack, yes. Okay, cross-site scripting, also. These are the two threats to applications, and not IP spoofing and port scanning. Okay, and then which of the following are device security risks? Vulnerabilities, yes. Weaker passwords, yes. Data transmission, inadequately encrypted, no. This is for transmission. And then user identity not authenticated, yes. So these are for device security risks. So you have to learn to differentiate between application security. So this is security in relation to the applications, the apps, and then device, it is for devices. So the devices here, they can have vulnerabilities, they can be configured with weaker passwords, and then of course, identity information could have been stolen, which can be used to log into these devices. So this is how you do it. So that is that on module 1. We'll move quickly to module 2 with our first topic, operating system overview. Okay. An operating system is a platform that manages computer hardware and software resources. It is required for the normal operation of the computer. During the development of PCs, there have been many different operating systems. The most commonly used include DOS, Windows, Linux, Unix, and OS. This course describes the Windows and Linux operating systems. So, if you are into security, you must be efficient in these two operating systems, Windows and Linux. Okay. Objectives. Upon completion of this course, you'll be able to describe the many functions of an operating system, describe features of the Windows operating system, describe the development history of the Linux operating system. Contents, operating system 101. Definition. An operating system is an interface between users and computers. So the thing is, the way it was a long time ago was that the computers were very big. They could, occupy the whole of this room, and the users, they were not seeing what they were doing, The programs, they were being programmed on punch cards. So they would program it on punch card, put it in the machine, and then they would receive the printout, That's how it was. During that time, there was no operating system. But now we have the operating system. We are able to see what we are doing because of the operating system. Manages all hardware resources and controls the execution of software, improves human-machine interaction interface, is a software program. So these are the definitions of an operating system. The many functions. One is processor management. So this is the main task of an operating system, is to locate, control, and manage processor resources. So this is the processor here. This is the part of a computer which does the thinking. So processor management include process control, okay? The managing and the controlling of the processes. So you see, when you open up Word, in the background, what you're creating is a process, okay? And then we have process synchronization. So this one, it deals with the processes that are executing concurrently and they are sharing the same data. Process communication, this has to do with data transmission between processes. And then we have got process scheduling. So here, of course, memory or processor power has to be assigned to different processes. And that is done by a process known as process scheduling. The other function of the operating system is memory management. So this one, it deals with allocating memory resources to programs. So you see, when you start Word, for it to work, it requires memory. That's how it works on a laptop. Whatever program you start, it needs memory, okay? So memory management has to do with memory allocation, the assigning of memory to different processes, memory protection. Of course, here, memory has to be protected. So you see, the operating system needs memory. So it has to be protected from the user processes. And then amongst the user process also, they have to be protected, when memory is being shared. And then we have memory expansion. So this is when we're dealing with big programs, or we are running multiple programs and we don't have enough memory on our system, okay? So memory management will be responsible for memory expansion. So this is whereby some of the stuff is sent to your hard drive. such that when memory frees up, that stuff will be taken from the hard drive to the RAM. The other function is device management. So the main task of device management is to execute input and output requests, okay? Classify input and output devices. Now, these input and output devices, we call them peripherals. So these are the devices that we connect to the laptops, okay? For example, the mouse here, the peripheral, it's an input and output device, Now, device management is responsible for what is known as buffer management, okay? For example, the printer is also called a peripheral, okay? So the printer can be working at a different speed with the laptop where it is connected to, okay? So we need a buffer for that. So buffer management is the one which does that, making sure that there is synchronization between the printer and the computer, where it is connected to, okay? Device allocation, as well as we have got device virtualization. So device virtualization, this is whereby we create, logical sections. Like on this same computer, I can have a virtual machine, and on that virtual machine, I can install another operating system that is on the same laptop. I can have two different operating systems or two different systems, one running on Windows, the other one running on Linux. Why are these two running? It's because of virtualization. Virtualization has made it possible. File management. So in modern computer systems, programs and data are stored as files. So the main task of file management is to manage user and system files. And file management facilitates file usage and security. To achieve this, file management should provide functions such as file storage space management, read and write management, directory management, file sharing, and protection. Then we have job management, which provide a stable environment suitable for users to effectively organize their workflows. So job management should provide task and interface management, human-machine interaction, graphical interfaces. So this is the graphical interfaces here, and then language control. Operating system categorization. How do we categorize the operating systems? One, by application domain. So this is where we have desktop operating system, server operating system, embedded operating system, okay? A server is a device, it is a computer which provides the services, okay? An embedded operating system, of course, we find these in different devices now. In fridges, modern fridges, they have embedded operating systems, cars, and so on. We can categorize an operating system by the number of supported users. So this is where we have single user operating system, where only a single person uses it, or multiple user operating system. And then we can also categorize the operating system by the openness of source code, okay? For example, Linux and FreeBSD, these are open source. What do I mean? I mean that you can get the code of Linux operating system and change it to suit you. And then we have closed source operating systems. So these, we don't have access. Windows will never going to give you access to the code of Windows. Okay, that's how it is. Windows operating system. So the origin of Windows started in 1985. Okay, and then we had development in hardware and software, which led to, to have Windows XP, Windows 2000, Windows 8, Windows Vista. Up to now, we have Windows 10. Okay, so Windows, of course, it is user friendly. This is the system architecture of Windows, which has 4 processes. System processes, which deals with login and sessions, service processes, applications, as well as environment sub interfaces. Okay, and then these, of course, they are in what we call the user mode. So these, they run in the user mode. Then we have the other mode, which is the kernel mode. Okay, so the main operating system is here in the kernel mode. So this is where we have Windows executive entities, such as, the memory manager, process manager, and others. Windows kernel, which is the main part of the operating system, device, drivers, and then we also have the hardware abstraction layer. So this is the layer which separates the kernel from the hardware. And then, of course, we have Windows and graphic system, which we use for the graphical interface. This is the Windows family, which I talked about. So there was Windows 1, Windows 2, and so on. Okay. So as I said, we have personal computers and servers. What's the difference between these two? Okay. So in terms of graphical user interface, personal computers are better than servers. Okay. But when it comes to the number of users or the number of services, servers, they accommodate a large number of services and a large number of users. Therefore, they have more processor power when you compare them to the PCs. Okay. So features of Windows. Windows is easy to use and easy to learn. It is the most widely used and most compatible operating system worldwide. It has got neat user interfaces, various device independent graphical operations, and of course it is mount user and mount tasking. That is, you are able to do so many things on your laptop. Applications of Windows, where is it applied? Of course, in offices, enterprise servers, on ATMs. Your ATMs, they use Windows operating system, as well as, in mobile phones. Linux operating system. So this is the history of Linux. So before Linux was developed, we had Unix and Windows operating system. Okay, and then Tannenbaum developed a Unix-like operating system called Minix. Okay, Linus then created his operating system kernel based on Minix. Okay, and then later he came up with Linux, which is free of charge. So how did he, choose this logo here? Anyway, there are two versions. One version was that, he was, beaten by, this creature. The other thing is that these penguins, they are found only in the South Pole. And of course, the South Pole does not belong to anyone, just like Linux. Linux does not belong to anyone. It belongs to the group of programmers. So it is, open source. So anyone can use it. Anyone can get the source code. This is the system structure of Linux, where we have hardware. We have, of course, the kernel. And then this is the shell, which gives us the user interface. And then we also have the file system, extension 1, extension 1, 2, and 4 now. And then, of course, we have different applications such as the Office suite and others. So these are, distributors of Linux that are there. They are distributors it depends on what they have done to the kernel and the packages that they have. So we have Ubuntu, CentOS, Fedora, Red Hat, and others. What are some of the main features of Linux? It is free of charge, mount user, mount tasking, user-friendly interface, and of course, it supports multiple platforms. How about applications? So you can see that Linux is used in military equipment, in servers, in networking devices, as well as in gaming consoles. So the thing here is that you must know Linux to the fullest because most of the tools that we use in security, they are Linux based. Why? It is because the programmers, they have got access to the source code. Therefore, they are able to develop whichever tool they want. Okay, so very, very important that you must be efficient in Linux. So comparison between Windows and Linux. So you can see in terms of cost, Linux is free. Software supports, Linux supports a small number of software programs, while Windows, many. Security-wise, you can see that Linux has low risks of virus infection. Why? It is because of the way it was designed, the way the file system was designed and the permissions. Well, you can see here, Windows, it needs frequent patching, So it is high risk of virus infection. And then usage, Linux, it is difficult for beginners, but learning and guidance is required, okay? Windows, easy to use for beginners, okay? And then, of course, Linux, it is open source. Windows, it is closed source. We come to the quiz. Which of the following is not a feature of the Windows system? So you see, you read a question after question, you can see this one, D, free of charge. Windows is not free of charge, okay? So make sure you have to pay attention of words such as not. So if you see, if you are quick, you can just go, which of the following is a feature of Windows system? That is when you are panicking. And then A, unified, friendly, neat, you know. So when you are in a hurry and you are panicking, you are going to pick A. So please make sure you take your time. Which of the following is not? Okay. So this feature here, Windows is not free of charge. Okay. All right. So for today, that is that. So from now onwards, this exam is not a joke. You have to study, and you have to study hard. Okay. So thanks a lot for your time. Thanks a lot for attending. Tomorrow, we are going to continue from here. Have a good night.
Are we